Alrighty. So, first thing we need to do is change 5 pi over 6 into degrees. Now this is super simple, guys. 5 pi over 6. What's pi?
180
What's 180 divided by 6?
30.
30 times 5? 150. So it's 150 degrees. That's all there is to it. I'm not going to give you something wild and wacky with a 13 or something in it. It's going to be easy. Pi is 180. Now, going the other way isn't quite as easy. This is where we want to set up our proportion. And what does our proportion look like? Pi over 180 equals x over 140. You want to have your degrees on the bottom. So pi over 180, x over 140. These are the degrees, right? So we'll cross multiply and divide by 180. And so we have, so the zeros will cancel out. So now we have 14 over 18. So those are both divisible by 2. So we have 7 pi over 9. So the answer is 7 pi over 9. This practice quiz is in Schoology. I would strongly suggest that sometime between now and Tuesday, you go in there and do it again. Okay, this can be like your first copy, but go in and do it again. Find the degrees, minutes, seconds. So we got to get our calculators out. So we type in 211.764. And then where do we go once we get that number typed in? Second angle or second apse, yep. And we go down and choose option 4, DMS. And it says 211 degrees, 45 minutes, and 50.4 seconds.
Yes.
Okay, now we got the same thing, convert to decimal degrees. So we type in the 153, and then, what? Second angle, and get the degree mark. Then we type in 19, second angle, and get the minute mark. And then 57, and how do I get my seconds? Alpha plus, yep. And I got, does it tell me how to round? Nope. So I got 153.3325. There'll be directions on the quiz how to round, but there's your decimal degrees. What pops into your head when you see a picture like this? And I didn't even put a variable on there. You're finding x. X is the arc length. That's my bad, as you guys say. This is x. And this is 4, and this is 1.8. What pops into your head? Arc length equals radius times radians. So arc length equals radius times radians. Now the good news is the radius is 4, and the angle measure, this is the angle, and the angle is 1.8 radians. How do I know that's radians? No degree mark. If there's no degree mark, it's a radian. So this is just 4 times 1.8. So what is that? 7.2? Now this said inches on the radius, so your arc length is also inches. So your arc length would be 7.2 inches. that unit matches your radius unit. What angle measure describes west, northwest? All right, so let's look at our compass. Where's west? Where's north? So these are the two directions that are involved in the problem, right? West, northwest. So if I were to split that like that, that would give me northwest, right? Now, I'm going to split again, and I need to either split on the bottom or the top. This is west, northwest, so I will split on the bottom right here. So this angle right here, or this line right here, is west, northwest. Now the angle, which is what I'm looking for, the angle has to be measured from north. So I got to get all the way around to that west-northwest line. And I measure from north.
So wouldn't it be 270 plus 20?
It would be. This much is 270, right? To the west is 270. And then I need another 22.5. So 270 plus 22.5, 292.5 degrees. That's your answer. Remember, each big section is 90.
Yes.
When you split the 90, it's 45s, and when you split those, it's 22.5s.
If it was saying like northwest, north or whatever, would it still be 22.5?
All of these little divisions, when you put those dividers in, are 22 and a half.
So you would do the same. It would be the same number.
No, because if you were going up here, you'd have to go all the way to northwest and then another 22.5. So it'd be 270 plus 45 plus a 225, or plus a 22.5. All right, fill in the blanks, and there are a bunch of them. So what do we know?
10 and 3 on the floor.
Well, don't we know right off the bat that the sine is 3/4? Because the cosecant is 4/3,
Yes.
right? Okay, now I need the cosine and the tangent. And I need the secant and the cotangent.
Is this the A squared, B squared?
Well, it's going to be. First thing I need to do is draw a picture of what I know. So I know, here's my triangle, the same triangle I always draw. Right here, right? There's my triangle. There's my theta. Theta is always at the origin. And I know that the sine is 3/4. So think SOHCAHTOA. Opposite is 3 and hypotenuse is 4. Is that good with everybody? So now, Ari, is when I need to do the Pythagorean Theorem, because now I have two sides labeled and I need the third side. So x squared plus 3 squared is 4 squared. X squared plus 9 is 16, so x squared is 7, which means what's x?
7.
Square root of 7, right? You got to take the square root, so it's the square root of 7. Now, can we fill in the rest of it? What's cosine?
37 over 4.
Adjacent over hypotenuse, which means its reciprocal is 4 over root 7, or 4 root 7 over 7.
I'm confused.
By what?
How is 7 the adjacent?
It's the square root of 7.
Oh, okay. I thought it was across from the 4, so would it be the opposite?
This is the angle. This is opposite, this is adjacent, that's hypotenuse. What's the tangent?
3 square root of 7 over 7.
So yes, 3 over square root of 7, which is 3 square root of 7 over 7 when I reduce it, yep. And then the cotangent would be root 7 over 3?
Yeah.
This guy right here. Number 8, find the exact value of the cosine of pi over 4. Now you guys, anytime you have the word exact, it means no calculator. So I don't want to see some crazy 0.706321. I don't want that, no. The exact value needs answers like this. These are exact. I didn't do this on my calculator. There's no decimals here. So what's the first thing I need to do when I see cosine pi over 4?
Can you put that in the calculator? If it says it can?
What do you want to put in your calculator? No, we're not going to type this number into our calculator. No. Caroline?
It's gonna be 45, so 180.
Okay, so that's the first thing you want to do. Ari, I just got done saying the word exact means no calculator. Okay? So we don't want to do any typing in and rounding off and approximating and all that. So Caroline's right. The first thing I need to do is recognize that 180 divided by 4 is 45. Now, I don't care if you use a calculator for that division, because you're not rounding anything off. You're just figuring out what 180 divided by 4 is. That's 45. Now, at this point, we don't need a calculator anymore, because I know what a 45-degree angle looks like. Notice that's exactly the same picture I drew for the last problem, only this time that's a 45. What do I know about these sides then in a 45, 45, 90? 1 root 2, right? Now, I need the cosine. So what do I know about cosine? Adjacent over hypotenuse, so ka-toa. Write that down on the top of your paper if you need to. So ka-toa, so it's adjacent over hypotenuse. So 1 over root 2, which I'll rationalize and end up with a final answer of root 2 over 2.
Yeah.
Now, type cosine 45 on your calculator. That is the decimal approximation. When it says exact, that isn't what we want. Okay? When it says exact, you're doing exactly what you did. You're drawing a picture and setting up the fraction. Now, the next one is a calculator problem. See, round to the 10,000th? That means, okay, let's approximate. How do I type secant 200 on my calculator?
1 divided by 200?
1 divided by cosine 200. Right? 1 divided by cosine 200. Because secant is the reciprocal of cosine. So 1 divided by cosine, my answer is negative 1.0642. Is that what you got?
Yeah.
If you didn't get that, you might want to double check, make sure your calculator's in degrees. Remember, that makes a difference. You need to be in degrees.
How do we do that again?
1 divided by cosine 200. All right, 2 more to go. 10 is no calculator, and 11 is with calculator. So here we go. Number 10. Find the missing angle without your calculator. So here's the same picture I always draw, right? And theta's right here. The angle is always right there, and I don't know the angle, so they call it theta. But I know that the tangent is root 3 over 1. I would put that over 1 because all of them are always fractions. Sine, secant, they're all fractions. So what does that tell me about my picture?
It's a 1, 2.
It's going to be a 30, 60, 90. And the root 3 goes here and the 1 goes here because tangent is opposite over adjacent. And as soon as you put a root 3 and a 1 there, you know that angle has to be 60 degrees. Because the 60 is the one across from the root 3. The 30 is across from the 1. So the answer to the question is 60 degrees. And then the last potential quiz problem. Remember, these are potential problems. You probably won't have to do all 11 of them. These are the things you need to know how to do. And remember that on actually Monday and Tuesday, we have office hours. Monday they'll be virtual, but Tuesday they'll be in person. All right, need an equation. It's going to be sine, cosine, or tangent. Always, 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 always sine, cosine, or tangent. What do you think? Why do you think tangent, Daz? Exactly. He says, look at this angle sitting right here. This side over here is opposite, and this side right here is adjacent for that angle right there. Opposite, adjacent. This is the hypotenuse. But the hypotenuse isn't part of the problem. It's not labeled or anything. So I need to come up with a function, sine, cosine, or tangent, that uses opposite and adjacent. Well, that's tangent. So tangent 37 equals opposite over adjacent. And that's going to be 5 over x. It's opposite over adjacent. So label your sides. So when you plug them into your equation, you get them in the right spot. So then we multiply by x. And then divide by the tangent of 37. Because we want to know what x equals. So on my calculator, 5 divided by tan 37, I got, for my adjacent side, 6 point, does it tell me how to round? 100? So it'd be 6.64. All these problems came straight out of your notes. So you can go back and look at your notes for more practice. I gave you a practice packet the other day that's got some of these, it's got other stuff in it too, but it has all these problems in it. So you kind of sort through and pick those out. Right? That's our quiz. Okay. Now, let's get our notes out.
Is it 4? Can I use the restroom real quick?
Yep, sign out. Draw a line. Okay.
This class is getting so slow today.
Okay. All right. Now we are going to, we're on page 34 of the notes, I think. So we're finishing up 4.2 today.
This isn't
are gonna be on our quiz, right?
Okay. From the beginning of the year, what's on the quiz? What's on the practice quiz? So if it's on the practice quiz, it could be on the quiz. Nothing else is ever on any of the quizzes or tests we take. Only what's on the practice I give you. Okay? Always. All right, here we go. Draw a picture, write an equation, and solve it. Round to the nearest hundredth. So this is a little bit different because you wrote an equation in this problem, but the picture was given to you. So now you have to actually draw your own picture. And it will look something like this. Let's see. We have a squirrel in the top of a tree. So I'm going to draw my tree. Here's my tree. And here's the squirrel on the top of the tree. The tree is 52 feet tall. So I'm going to put 52 right there because that's the tree. So far, so good? The squirrel is looking at a nut on the ground. So here's the situation. The squirrel's sitting up there in the tree, and he's looking at a nut on the ground. His angle of depression is 23 degrees. Now, you studied these back in geometry. So I want you to put your pencils down and look at me. The angle of depression technically is right here. Okay, you're not writing it down now. The angle of depression is, if I'm looking straight ahead and then I look down at something on the ground, that's my angle of depression. The problem with it is, it isn't even in my triangle. So from geometry, I know that that angle and that angle are alternate interior and therefore congruent. So that's where I want you to put the 23. And then I want you to make a little note, so you can pick your pencils back up, make a little note that you will put every angle of elevation or depression, either one, every angle of elevation or depression is going to go right there. Every time.
So, isn't it? So, like, the angle of depression you said was 23, right?
Yep.
And you drew that, like, dotted line up there. But couldn't it just be, like that's, it's a right angle once you put that, like, include the angle of depression? So can't you just subtract by 90?
And use that angle?
And, like, have that say 67?
Sure.
And
I don't know why you would do that, because when it says 23 degrees, you're always going to be given either an angle of elevation or an angle of depression.
Yeah.
They both go right here. So if you want to mess around subtracting and doing all, fine, that's fine. But there's no need to do that. The 23 goes here. The angle that you're given is going to go here every single time. Because if that one's 67, this one has to be 23 anyway.
Yeah.
Yeah. Yeah. So every angle of elevation or depression is going to go right here. Now, what else do I know? Or what do I want to know? Find the distance from the nut to the base of the tree. So where does X go? Does X go on the hypotenuse?
Jason.
X goes here. Because isn't this the distance from the nut to the base of the tree?
Mm-hmm.
What would this be? This could be a question, but what question would this be? From the nut to the squirrel. If I wanted to find the distance from the nut to the squirrel, then my X would be up here, right? This is an N for nut. All right, now, there's your picture. Looks just like that one over there. What's my equation? Tangent again, because I don't know anything about the hypotenuse. I just know opposite and adjacent. So tan 23 equals 52 over x. So what do I do to solve that? multiply by x. And then I'll divide by tan 23. So how far is the nut from the base of the tree? 52 divided by tan 23. 122.50 feet. Now this is a word problem, so we got to put units on it. And since this was 52 feet, this is going to be feet. 122.50 feet. That's not bad. That's not bad. Let's practice another one. This time we have a seagull on top of a lighthouse.
Thank you.
So here's my lighthouse and here's my seagull. Okay? And he spots a fish in the water. So he's up here and he's looking down at the water and he sees a fish. The goal is 87 feet above sea level, so this is 87 feet. And the goal is 230 feet from the fish. The goal is 230 feet from the fish. Where does the 230 go? Hypotenuse. Don't overthink it, you guys. Don't overthink it. Here's the goal, here's the fish. This is how far apart they are. How far apart are my fingers? 230 feet, right? What do I want to know? The angle of depression. Now remember what I told you. Every angle of depression or elevation is going to go in that spot. Right?
Yeah.
Okay, now this one's a little bit different, but we're going to set it up the same way. Here's the angle. I don't know what it is, but this is the angle in the problem. So which sides do I have with regard to that angle? This is opposite, and this is hypotenuse. So I'll use sine. And my equation will be sine x. Because remember, when you write your equation, it's always sine angle. Right? So sine angle. In this case, that's sine x. Equals 87 over 230. Now, this is where you don't do what I think you want to do. You probably want to do something like times by 230 or something. No, no, no. This, no, no. There's no, you're not doing any math operation. To find an angle on your calculator, to figure out what x is, we have to use a new button on there. If you are looking for an angle, you use second sine. If you want an angle, you are going to use your second sine, second cosine, second tangent button. Okay? When do I use those buttons? If my angle is x. If I don't know my angle. If I don't know my angle, I'm going to second sine my fraction. So second sine, and that's, you found it, right, above sine there. So second sine, 87 divided by 230. That angle is 22.23 degrees. That is the angle. Press second sine, and then 87 divided by 230. Okay, did everybody who has a calculator get 22?
Yeah.
Are you in degrees?
Yeah, I'm sure. That's probably it. I'm in reading.
Okay, gotta be in degrees, right? If you want a degree measure, gotta be in degrees. Okay. Now, I don't want anybody in this room getting confused about when I use regular sign and when I use second sign. If you know the angle, you use regular sign. If you don't know the angle, you have to use second sign. That's easy. Look at your picture. Do I know my angle? If I do, it's regular sign. If I don't, it's second sign. Or cosine or tangent, depending on the equation. All right, let's try C. You're doing great. Gotta hang with it, folks. Zoning out just means you're going to be behind because we're not reteaching stuff. You gotta keep plowing ahead. Here we go. How far is an airplane from the airport if he is currently 5,000 feet above the ground? All right, so I'm going to start right there. Here's my plane, and it tells me that he is 5,000 feet above the ground. Does that make sense to you?
Yes.
The pilot's angle of depression is 17 degrees. So remember, this is the airport down here. Every angle of depression or elevation is going to go right down here on the ground or whatever you want to call this. How far is the airplane from the airport? So that's my X. How far is the airplane from the airport? Where am I going to put my X?
Is it adjacent?
Is it what?
Adjacent?
Actually, it's here. And I get kind of where you're coming from, Ari. I understand that. What I want you to think about is, I want you to take your finger and put it on the airplane. Take your other finger and put it on the airport. And the distance between your fingers is the question. Right? So that's X.
Okay, so it's hypotenuse always gonna be distant?
Well, it's always going to be the distance from something up here to
Because
something down
saying
here.
as far as from what it's always that's gonna be it.
Well, yeah, if something's up here and something's down here, then that's going to be the distance between them. Is it cosine? I don't think so.
No.
I think it's sine, isn't it?
Sign.
Oh, it's.
So sine 17 equals 5,000 over x.
Yes.
So x sine 17 equals 5,000. And x is going to equal 5,000 over sine 17. Would you agree with that?
I would.
So let's type it in our calculator. Now, am I using second sign or regular sign? Regular sign, yeah. So 5,000 divided by sine 17. And I got 17,101.52 feet as my answer. Remember, you have to label. If it's a word problem, you have to label it. Now, would you read question D and see how far you can get with the picture? Notice that your triangle always has a structure like this. So hopefully the thing you draw will end up looking like one of these triangles. Okay, we're working on D. Did you draw a flagpole on the ground like this? And did you put X here because you're finding the height of the flagpole? And did you put the angle of 59 down here? Did you say no?
I said yeah.
Yeah.
I have a question. So when it says angle of depression and angle of elevation, are those the same thing?
They're the same thing. Well, they aren't the same thing, but they're always equal.
Okay.
So you put them in the same spot every time. Now, this is the tricky part. Where did you put the 13?
I'm on the bottom.
I heard bottom and I heard hypotenuse. Where do
It's
we
bottom.
think the shadow goes?
It's bottom.
On the ground. When we see a shadow, like if somebody came in behind me with a flashlight, where would my shadow be? Would my shadow be diagonal? Heck no, my shadow would be down there on the ground, right? Okay, what function to write my equation? Tangent? Tangent? So tan 59
X over 13.
equals x over 13. Now remember, you're getting rid of the fraction, so you'll multiply by 13. So 13 tan 59 will give you x. 13 tan 59, that flagpole is 21.64 feet tall. Does that look okay to everybody? Is that what you're getting?
Wait, what'd you get? 21 points. Yeah.
All right, one more, and then we'll move on to the next thing. That I think these are fascinating, but obviously some of you don't. Here we go. What is the angle of elevation of a man looking at the top of a building that is 48 feet tall if he is standing 100 feet from the building? Okay, so you've got a building, and we know the building's 48 feet tall, right? And the man is looking up at the top of the building, and his angle, I don't know the angle, right? That's X.
That means it's going to be the negative.
It's going to be a second something, right, after I build my equation. What do I know? Oh, the man is standing 100 feet from the building.
So that goes on the adjacent.
That goes on the adjacent. Very good. Very good. Because if I said to you, how far am I from the building, wouldn't you go here? This is how far I am from the top of the building, but I don't want to know that. That's not how we talk about it. The distance, if we're measuring the distance from me to that wall back there, it's on the ground. That's the distance we're measuring. So what function? Sine, cosine, or tangent? Tangent. So we'll say tan x, because the angle is always attached to the sine, cosine, or tangent, equals 48 over 100.
So if x equals tan to the negative first.
Yeah.
48 over
So you need second tangent 48 over 100. Once you write your equation, you're done. No multiplying or dividing or anything like that. Once you write your equation, you go straight to second tangent. So second tangent, 48 divided by 100, 25.64. And that unit would be degrees. It's an angle. Okay?
So, do you have to use the variable x, or could we use theta for that?
Oh, you could use theta, absolutely. You could use theta. You can use whatever variable you want. Yep.
4.2 over
Yep, you conquered 4.2. Now, 4.3 is, if you look at the problems there, it's like find sine, cosine, tangent, all those things. We've already done problems like that. The only difference here is we aren't drawing our triangle in quadrant 1. For the first problem there, problem A, we are actually drawing a triangle down in quadrant 3. Now, so this is a new thing for us now. We're moving out of the first quadrant. Every picture, every time we set up one of these theta things, one of these theta triangles, we've drawn it in quadrant 1. So all of your pictures, and I keep harping at you, this is the way the triangle looks, right there. That's the way it looks. Well, that's the way it looks if you're in quadrant 1. But trigonometry exists in all of the quadrants. So if you're in quadrant 1, you'll draw that triangle. But if you're in quadrant 2, you'll draw this triangle. If you're in quadrant 3, you'll draw the one I drew over there. So quadrant 3 triangle would look like this. Now, once in a while, you'll have a problem where you're going to draw them all, but usually you're only drawing one of these. And in quadrant 4, we have the purple triangle. So depending on where you are, those are the triangles that you'll draw. Notice there are no sideways lines, right? No sideways. All your lines are up and down. I mean, you've got the angle coming out, but then you've got up and down lines. So don't be drawing a triangle this way. We call this the butterfly bow tie. Every angle that you draw will be a butterfly bow tie. One of the pieces of it. Okay, one of the pieces of it. So, how do I know this angle is in quadrant 4, or 3, I mean? Well, they drew it for me. But I would have known that anyway, because the point is -3, -4. And we have a negative x and a negative y only in quadrant 3.
How do you know that you put the -3 and -4 in those two spots?
Because this is a regular coordinate plane. Isn't this way x and this way y? So when the point is -3, -4, x is -3 and y is -4. Now, if I want to know sine and cosine and all that, don't I need my hypotenuse? Or this thing right here? So what will I do to find it? Pythagorean Theorem. These problems are just like the other ones, except we're not in quadrant 1. But otherwise, they're exactly the same. So square that, you get 9. Square that, you get 16. And I want to know what the hypotenuse is.
Yes.
So 25 equals x squared, so my hypotenuse must be 5. Now, here is something really, really important. The hypotenuse is always a positive number. So, obviously, x can be negative. It can be positive or negative. Y can be positive or negative. But the hypotenuse is always positive. Always positive on the hypotenuse.
So, hypotenuse is always like C in the
C, in the Pythagorean Theorem. Yep. Yep. Okay, so there's my triangle. Here is my theta, right here at the origin. Theta is always the angle at the origin. So now you should be able to fill in your functions. So sine, cosine, tangent. And there's no radicals in this one, so it should be easy. And then cosecant, secant, and cotangent.
It really bothers me that it's upside down.
That the triangle is?
Yeah.
Can't help it, it's in quadrant 3. It doesn't change a thing. This is still the opposite side. And this is the adjacent side. And this is the hypotenuse. So here we go. What's the sine going to equal?
-4.
Negative 4/5. Remember the other day when we were typing this into our calculators and one of them came out negative and you were like, wait, negative? And I said, hey, that's okay. Well, yeah, because in the different quadrants, you're going to have negatives floating around. All right, what's cosine?
-3.
-3/5. Yep, -3/5. And what about tangent? Actually, the tangent will be positive
Because it's-
4/3.
Yeah.
because it's negative over negative, right? So the tangent will be a positive number because it is technically -4 over -3.
Yes.
So now we can do our reciprocals, and what are they?
5 over -4.
Yep.
5 over -3.
And 3/4. Now, when you write a fraction, where you put the negative isn't important. So it looks like, this looks like -4 over 5, but when I flipped it, I left the negative up on top, that's fine. Or you can put it in the bottom, it doesn't matter. -5 over 4 is the same as 5 over -4. So don't get hung up about, where do I put the negative? Doesn't matter, just put it. Well, that was exactly what we've done before. We just have negatives now because we're in a different quadrant. Let's look at the next one. This one, Mary Kate, is going to be in quadrant 4. So I will draw my butterfly bow tie in quadrant 4, which is right there. This is my angle. And what is my x and my y in this problem?
1, -2.
My x is 1 and my y is -2. So this will be my adjacent and this will be my opposite. Do your Pythagorean theorem and tell me what you come up with for your hypotenuse. Vincent? Head up, hood off. Thank you. Gabe? Square root of 5, very good. When you do the Pythagorean theorem, you are squaring, so there are no negatives in your Pythagorean theorem. It's 1 squared plus 2 squared, so this is the square root of 5. When you square the negative's gone. Don't have any negatives in your Pythagorean theorem. Here we go. What's the sign?
2 squared 5 over 5.
Very good. Actually, it's negative. Did you say negative?
Oh.
It's -2 over root 5, which is -2 root 5 over 5. If you're using the 2, it's got to be negative. All right, what's my cosine? One over root 5? Or root 5 over 5? Now that one doesn't have a negative because x is positive. How about my tangent? -2 over 1 or just -2, if you prefer. And my cotangent. 1 over -2. Oh, and my secant.
5 root 5 over 5.
Okay, that simplifies. Remember, we said it's easier to flip here?
It's just root 5.
So it's just root 5 over 1, or just root 5. So Mary Kate, there's nothing wrong with your answer, except it's not simplified, because you went the long way, which is fine. Let's simplify it. And then this one is going to be root 5 over -2.
Yeah.
You're doing great. You're doing absolutely great. We're going to do one more problem, and then we'll be done for the day. Hang on. One more. Quit it. One more problem.
Nice and easy.
You guys act like this is the worst thing you've had to do all
I
day.
actually have like physical pain.
Oh,
This
stop
is
it.
my favorite class.
Of course it is.
This is the only thing I'm like actually understanding in school right now.
Okay, well, good.
To this class
I don't know
All right.
why. Like,
Here we go.
Everything she's ever taught us.
Problem C, last one. This one is in quadrant 2. So I will draw my triangle
Let's
in quadrant
go.
2. Even if the picture weren't there, I would know it's quadrant 2 because the x is negative. This is the x-axis. The x is negative and the y is positive. So who can tell me the hypotenuse?
It's gonna be radical 10.
Radical 10 is absolutely right. So you're fighting through your pain, Mary Kate, and doing your Pythagorean Theorem. Root 10. So my sine is 3 over root 10, step 1, which is 3 root 10 over 10. Would you agree with that, Caroline? Okay. What's my cosine, Katie? Okay, you gotta pay attention here. It's hard stuff. Gotta stay on top of it. What's cosine? Ari?
Is it negative 1 over square root of 2?
It is.
Square root of 2.
Yep, that's exactly right. That's exactly right. And remember, you can put the negative wherever you want to put it. There just has to be a negative in it. What about my tangent?
3 and 3.
-3. It's actually it's 3 over -1, but that's the same as -3.
Yeah.
And then we'll flip them. So flip this, you get root 10 over 3. Flip this, you just get negative root 10 over 1, or negative root 10. And flip this, you get negative 1/3.
We done.
And we'll stop there. Even though we probably could get another one done, we'll stop there. Annie, you have to hang on for the blessing. And I've got kids coming in after school, so we need to clean